So, good day everyone. So, I am Shianell and I will be discussing to you about friction, and this is our topic for simulation project proposal. So, let's start. So, let's define friction. What is friction? So, friction is a type of relative force that acts as a resistance between two bodies that are in contact with each other. So, kung ang two object daw kay in contact with each other kay ang mag-resist ana nga force kay ang friction. So, the amount of friction depends on the materials from which the two surfaces are made. So, kung mas rough ang surface, mas daghan og friction ang maproduce. And then, friction also produces heat. So, when you rub two hands together, so kung i-rub ninyo ang inyong kamot together quickly, kay muinit siya, mabantayan man ninyo ba nga muinit siya kung i-rub ninyo ang inyong kamot. So, that is friction. So, this is our learning objectives for our project proposal. So, in the end of this activity, students will be able to, number 1, identify the relevance of friction to the temperature. Unsa man ang connection sa friction sa temperature. And number 2, to understand the practical application of friction in daily lives. Naa ba kahay mga application sa friction sa atong adlaw-adlaw nga kinabuhi. And then number 3, to determine the effect of rubbing two books to each other. So, this number 3 kay ma-found out ni nato siya mo niya nga muang kuan sa PET nga app. So, this will be discussed furthermore later. So, let's move on to the next. So, this is our basic concepts of friction. So, number 1 is friction is the force that resists the sliding or rolling of one solid object over another. So, as I say, nga friction, ga-resist siya sa motion or sa action sa, for example, sliding or rolling of one solid objects to over another object. So, number 2, naay duha ka main types of friction. So, this is the kinetic friction and the static friction. When we say kinetic friction, kay mag-act ni siya between moving surfaces. When we say kinetic, moving. And the next is static friction. So, ang static friction kay mag-act ni siya between sa surfaces nga at rest with respect to each other. So, at rest, static. So, number 3 is the application of friction. So, part sa atong objective ganina nga mabalaan nato nga kanang part ba ang friction sa everyday life. So, natay mga example dire. For example, when rubbing two sticks together, it will produce fire. So, garab man ka na may resist nga force ana, so that is friction and it will eventually produce heat o makaproduce dayon siya fire. So, it is really in our everyday life. And then, friction is also responsible for the wear and tear in bike gears and other mechanical parts. And then lastly, number 4, all the work done by friction force results in transfer of energy into thermal energy. So, according to the law of conservation of energy, or no energy is destroyed due to the friction, though it may be lost to the system of concern. Energy is transferred from the forms into thermal energy. Energy lost to a system as a result of friction is a classic example of thermodynamic irreversibility. So when we say thermodynamic irreversibility, it is the process that cannot be reversed in order to obtain the initial state of a system.
So, good afternoon, everyone. So, here I'm going to show you the related formulae for friction. So, the first one is the static friction. So, it is when an object is not moving. So, the first formula that we're gonna use is the F is equal to friction coefficient times normal force. So, to get the normal force, we need to use this formula, the lower of the bottom. So, N is equal to mg, where is equal to mass of the object, g acceleration due to gravity. And we can then determine the friction coefficient. So in this particular part, where static friction, what do you mean by static friction? Is when a object is placed onto another object and is not moving. So, like for example, we put a box on the table. So we will tell that some would tell that it has no friction, but it has. Why? Because it is the one that is holding the force or the friction to move the object. So for example, you put a box in a sandpaper, it might not even move because of the friction. While when you put it in a smooth surface or less friction object like an ice, it will move with just even with the fingertip. So force of friction is varied due to the surface of the object it is in. So that is it for the static. Now let's go on to this to the kinetic friction. So in this case, the surface is inclined, meaning movement is unavoidable. So here is the formula. So N is equal to mg cos, where standing for the angle of the surface is inclined to. So to get the friction then, we need to use this formula. Fk is equal to kfn, where Fk is force of kinetic friction, Uk coefficient of sliding friction, and Fn is normal force. So in this case, we're trying to test how the object will move in a certain inclination of a surface. So the higher the surface is inclined, or it is more higher, or the inclination is a bit high, so it is most likely that the friction will be much much present, so it can create heat. Now on this activity, which is the to prove this two things, we will need to use the smartphone and the PhET simulation app. So we're gonna go to the friction tab or the friction experiment, and we're gonna do the following. So we're gonna test how friction is applicable and how friction is applied to the object. So that is all for me. Thank you so much for watching.
So, hello, I am Gleziel Mae Villamor, and I am going to talk about the flowchart diagram and the activity procedure. So, these two are just the same, so I am going to focus here in the flowchart diagram. So, first we are going to prepare the materials. So, the materials are already mentioned by my group mates earlier. So in the PhET simulation app, in the PhET simulation app, we are going to apply friction between the books. There are two books there, the physics and the chemistry book. So, we are going to apply kinetic friction on the two books by rubbing the book to each other, and then we are going to measure the surface temperature. And then after that, we are going to apply static friction. And the same way with kinetic friction, we are going to measure the surface temperature. And then, after we measure the surface temperature of the static friction, we are going to compare their measure of surface temperature, the changes of their temperature. And then, after comparing, we are going to end the activity. So, that's it. So, as what I've said, activity procedures are just the same with the flowchart diagram. And then, next is the references. This is the references of this simulation project proposal. And that's all. This is the, I am Gleziel Mae Villamor, and this is the simulation project proposal of Group 3.